Well, here is a question on an inductance and capacitance circuit, and it talks about a charged capacitor being connected to an ideal inductor to form an LC circuit with a frequency of f is equal to 1.6 Hertz. At time t is equal to 0, the capacitor is fully charged. And at a given instant later, the charge on the capacitor is measured to be 3 microcoulomb, and the current of the circuit is equal to 75 microampere. What is the maximum charge of the capacitor? So here you have a fully charged capacitor, because it says at time t is equal to 0, the capacitor is fully charged, and it's connected to an ideal inductor, which means it has no resistance. So it's an LC circuit with no resistance. So what's going to happen is the capacitor is going to discharge, and that's going to build up a magnetic field around the inductor. So the electrostatic field collapses while the magnetic field increases. Now that sets up, as you can see, an increasing magnetic field around the inductor and a collapsing electrostatic field around the capacitor. So anyways, at a given instant, the charge is measured to be 3 microcoulomb. So the time is not specified. And at that instant, the current of the circuit is 75 microampere. So the time is not specified, and we're going to use the value of the charge at that instant on the capacitor and the current through the inductor at that same instant. We're going to use that to find the time at which this happens. Now we know that the charge on the capacitor is given by Q is equal to Qm cosine omega t. Qm is the maximum charge on the capacitor. Omega is the angular frequency of oscillation, and that is equal to, because Q at that instant is given as 3 times 10 to the negative 6. At the same time, if you take the derivative of this, you get I is equal to dq by dt, which is negative omega qm sine omega t, and the current is given as 75 microampere. So we have equations 1 and 2, one for the charge and the other for the current. If you divide equation 2 by 1, the qm's get cancelled, and you will get minus omega tan omega t is equal to 25. So now that gives us omega tan theta is equal to negative 25. Omega tan theta, and I've taken the negative sign to the other side. And that means tan theta is negative 25 by omega. But omega is 2 pi times f. And the frequency of oscillation is given as 1.6 Hertz. So we can use that to find omega as 10 radians per second. Plug that back into this equation, and you get tan theta is negative 2.5, and which gives theta is equal to negative 1.19 radians. Now, since we know that theta is omega t and theta is negative 1.2 approximately, so theta is negative 1.2 and we know omega, so we can find t using negative 1.2 by 10, that's equal to 0.12 seconds if you take time to be positive. Even if you take the negative value and continue on, you're going to get the correct answer. because that time is a part of the angle. So now what we do is we go back to equation 1, which is here. Q is equal to Qm cosine omega t is 3 times 10 to the negative 6. And plug in the numbers that we have to find the value of the maximum charge in the capacitor. Omega is 10 here and t is 0.12, and gives us 8.27 times 10 to the negative 6 coulombs, which is 8 microcoulombs. So that's the answer for that question. 8 microcoulombs. So that is how this problem is solved. Thank you. I hope you have understood the concepts involved in the solution of this question.